So a lot of the types of questions that we're going to see with geometric are going to be the same. So we'll probably go through this pretty quickly. A geometric sequence multiplies by the same number every time, from one term to the next. It multiplies. Does anybody remember what we call that number? Common ratio. And we will learn that geometric functions, like arithmetic, we looked at, they kind of looked a lot like linear. When we graphed them, they were in a straight line. Geometric behave like exponential, which I'm not probably very familiar with, if at all. We really didn't get into that in Algebra 2. The explicit formula for a geometric sequence is AN equals A1. Both sequences start with A1. Arithmetic, it adds every time, so there's a plus sign. Geometric multiplies, so there's a multiplication. Arithmetic adds a common difference. Geometric multiplies by a common ratio. And then the big difference is that there is an n minus 1, but it's not right beside of the r. Does anybody remember? It's in the exponent, yeah. So it's up there. But overall, like the formulas are kind of like, they're very, very similar. They both start with A1, add or multiply, the difference or the ratio, and then n minus 1. So write the explicit formula for, I didn't change that in the directions. For the geometric sequence, and then find G0, the zero term. Now, here's the difference, and I actually need to fix that, I forgot. I don't know why. Every other place I've ever seen this, it's always A-N. In pre-cal, they use A for arithmetic, and they use G for geometric, which kind of is nice, but also I'm not used to that, and I will probably put A whole bunch of times. So, find G sub 0. So, formula, Gn equals, what is my first term? 6. What is my ratio? What am I multiplying by? 1/2. Notice you're dividing by 2, but we don't talk about it in terms of dividing by. We multiply. So dividing by 2 is the same as multiplying by 1/2, and then n minus 1 goes in the exponent. And if we're finding the zero term, (1/2 to the negative first power is not negative 1/2. That negative 1 flips your fraction. So it's actually 6 times 2, which is 12. And if you think about that, the zero term would be the one before the first. Like, if 6 is my first term, the zero term will be before that. So if I'm dividing by 2 going this way, if I want to go backwards, we're multiplying by 2. So it makes sense that this one would be 12. So number 12, the formula starts with the first term, which is 1 times, what's my ratio? To the n minus 1. And I'm finding the zero term, which I could do just by going backwards. Like, that one would be easy to do without the formula. But this would be 2 to the 0 minus 1. So if we have 2 and we raise that to the negative first power, that's the same thing as 1 over 2. So 1 times 1 over 2 is 1/2. Which, if we went backwards, would make sense. If my first term is 1 and I go backwards before that, I would have 1/2. (13) is asking us to graph. When we graph sequences, what's the big thing about the sequences that we talked about in the previous lesson? They don't connect. Like they're individual points. That signifies it's a sequence. Because a sequence, you have term 1, you have term 2, term 3. You don't have term 1.5. You don't have term 1.36. So it's individual points. So if we're graphing number 11, the first term, so that's when your n or your x is 1, your first term is 6. The second term, when your n is 2, is 3. Your third term is 3/2, which is really 1.5. Your fourth term is 3/4. We kept going. It's going to start looking like that. That is the shape of an exponential function. We're going to really be focusing on those this first little chunk of time, this unit. Now your 0 term, I could have went back, but I didn't give you enough space up here to graph your 0 term. So from number 12, we could do the 0 term, because we found the 0 term was 1/2. The first term is 1, and then my second term is 2, and then 4, and then 8. So these do not fall in a straight line. They're exponential. So if you're just given this graph and told to tell me about it, you're going to know it's a sequence because you're going to know it's individual points. You're going to know it's geometric because it's not a straight line. It kind of curves down. So you could say this is a geometric sequence. And you could find, it's not as easy, like the common ratio is not really, it's not a slope. Like in arithmetic, it's a slope. It's linear, it's a slope. We'll look at how to find that in a minute. Just like with arithmetic sequences, you don't have to use G1 in the formula. You can actually use any term as long as you change the 1 where the n minus 1 is. So you can really use anything there. And the reason you would want to do that is because sometimes you are not given the first term. Sometimes it tells you, like, the fifth term is this. So instead of having to work backwards to find the first term, you can just use what you got. Makes it a lot easier. All right, find the common ratio between the two terms. So one term to the next, we're multiplying. Here, let's see. So if I'm starting at 5, going to 40, I'm doing times 2, times 2, times 2. What is, when you multiply 2 by itself every time, that's not times 6, right? Is that times 6? No, it's 2 to the 3rd power. So when we're dealing with exponential and common ratios, we've got powers. So to find, and we did this in Algebra 2, so it may look familiar, we're going to do some kind of root, because the way to get rid of an exponent is to do that root. So if you were getting rid of a squared, you do a square root. If you're getting rid of a cubed, you do a cubed root. So we're going to do a root. Now it's the type of root that it is. You do 5 minus 2. So if you're given the 5th and the 2nd term, you subtract those. Okay. If this was G1, G2, G3, G4, I do 4 minus 1, that's where this root came in. Because you're not multiplying it. When I go from 5 to 40, even though I've got 5 terms, I'm not multiplying by 2 4 times. I'm actually only doing it 3 times. So that's why it's, you subtract them. And then under the root, you divide. 1296 divided by 6. And that, now some of these you would have smaller numbers. What's the cubed root of 8? 2. That's a common. You could be, it's very likely that you'd be asked the cubed root of 8 without a calculator. You could be asked the cubed root of 27 without a calculator. What's that? 3. 3 times 3 times 3. But bigger ones where we're having to do 1296, calculators are something is wrong. Okay. So 1296 divided by 6 is 216. So this is really the cubed root of 216. If you go to alpha window, you don't have your calculators right now. If you go to alpha window, number 6 lets you type in any root that you want. Now you could do 5 minus 2. You don't have to simplify it. 1296 divided by 6. You can do it all in one step, and you get 6. So R is 6. Now you could also just guess and check. You could, okay, do 6 times, maybe you think it's 4. 6 times 4 times 4 times 4 times 4, see if you get 1296. But you might make a mistake. So number 16, determine R. I've given you the 4th term is negative 8 and the 11th term is 1 over 16. This tells me 2 things. One of my terms is negative, one is positive. My ratio is going to be negative because the only way I can multiply to get from one to the other is if it's negative. And also, I'm going from negative 8 to a little fraction. So my ratio is probably going to be a fraction. So we're going to do a root. It's going to be the 11 minus 4. This one you do, like when you're deciding what root, you need to do your largest term minus your smallest. Like 11 minus 4. And so then I would do 1 over 16 divided by negative 8. Let's do this one. And it's negative 1/2. Any questions on finding common ratio? most likely on AP questions, AP exam, you would be given like a graph and asked to find the common ratio. So we'll look at that in 20. I don't remember ever having to do this as on part of the AP exam. Do the root, find the ratio. All right, given G2 equals 6 and R equals 3, find an expression for Gn, which means write out the formula, and then find G6. So you're not given G1, so probably the easiest thing to do would be to manipulate your formula. Use G2. Why did I put in there? G2 times R, and then do n minus 2. Yeah, you could work backwards and just go ahead and find G1 in your head probably. Either works. So Gn, what is G2? 6. What is R? 3. So when it says write an expression for Gn, that's what it's talking about. It wants the formula. And then when we find G6, we're putting a 6 in for n. And if we do 6 times 3 to the 4th, we get 486. Questions? All right, number 18. Go ahead and fill out the formula, fill in everything. You don't have to actually solve to get your final answer, because that one would be some bigger numbers. But get to everything, get to where you're ready to type in the calculator. Alright, so if you changed your formula, you would have had Gn equals negative 64 times 4 to the n minus 4 power, because you were given the 4th term. And then you were asked to find G8. And you would have filled in an 8 for n. And, oh. You got this big number. You would not be expected to do calculations like that without a calculator. Okay. 19, basically the same. We're given G6, so I'm going to use G6. My R is 3. But I have to use n minus 6 in my exponent because I'm given G6 instead of G1. And I'll do that for you real quick. We don't want decimals if we can help it. 4/3. Alright, so number 20, you had a very similar question with arithmetic. I give you a graph. We know it's a sequence because they're individual points. We can also see on the axis it says n and Gn. But I asked for 3 expressions, 3 different formulas. So just like we did with arithmetic, let's just go kind of label all of our points, or as many as we can do. So this right here I would say G0 equals 8. The 0 term is 8. The next point, G1 equals 4. The first term is 4. G2 is 2. G3 is what? 1. And we could keep going because you could. What's the pattern? Multiply by 1/2. So your common ratio, if you look from one term to the next, you're dividing by 2 or multiplying by 1/2. So you know the next one would be G4 would be 1/2. G5 would be 1/4. But I only asked for you to do 3 expressions, so we can use any of these 3 to write a formula. I'm just going to do the first 3. Gn equals, so instead of using G1, I'm going to use G0, which is 8, times the ratio we said was 1/2, because from one point to the next, the y values are multiplying by 1/2. And then to the n minus 0, okay, you can put n minus 0 or just put n. And then we could keep going. Gn equals, this one is G1 times 1/2 n minus 1. So here I used first term and I used 1. I'm going to use the second term, which is 2, and I'm going to use n minus 2 because it's the second term. On a test, it would be very likely that you would see a graph like this and then have some multiple choice where you're not just necessarily given G1. Like likely you'd be given this one, and then your other 3 would just be wrong. But you'd have to recognize, hey, like I need to use the 2 and the n minus 2. It's okay. It doesn't have to be n minus 1 every time. Let's look at some multiple choice. Okay, right here, 21 and 22. So I want you to look at those. That's exactly what I just said. You're given a graph and you're asked to find the formula that goes with it. So look at that. See if you can answer 21 and 22. So if I was sitting there taking the AP exam, that's kind of what I would do. I would probably make a table because I like it in table form. And at first I kind of skipped. I didn't put the 0 and 1 because those weren't on whole numbers, so I wasn't for sure where they were. But I knew I had 2, 1, 3, 2, 4, 4, 5, 8. So then I could say, oh, my ratio is 2, which then I kind of backtracked. So I immediately said, well, it can't be A because ratio is 2, not 1/2. And then I said, okay, well, if I'm using, like if I looked at B, if it's just 2 to the n, that's my 0 term. I should have had a 1/4 there, so it's not B. C, if I have n minus 1, I should have a 2 multiplied in the front. It's missing that. And then if I had an n minus 4, that's the 4th term. I had a 4 in front. And then for 22, when your points alternate, your ratio is going to be negative. So same thing. I started with the table. I said, okay, 1, 4, 2, negative 2, 3, 1. And then I was like, ooh, I'm multiplying by negative 1/2 because my signs are flipping, and then it's 1/2. So I immediately said, well, it can't be A or C. And then I went to B. If it's n minus 1, that's talking about my first term. My first term is 4. I went ahead and checked D just to make sure I didn't do something silly. If I just have n, that's your 0 term because n minus 0. If I worked backwards, my 0 term would have been negative 8. So that's why this one was wrong. because if that was a -8, D could have been right, but it's not. Okay. 23 tells us we have an arithmetic sequence. That's really important. B and C are constants. So your table does not go up by the same amount every time, but we do have at least 2 points, so we can find the common difference. So if you have any 2 points, I didn't have to pick out the 5 and 7, but because I know it's arithmetic, I know there's a common difference. So pick out 2 points, find the slope, because the difference is the slope. Okay. So to get C, that's easy, because that's the 7th term to the 8th term, it's got to be 23, because it's subtracting 3 every time. You could just kind of count your way backwards to get to term 1, to get to where B is. You could also do it with the formula. If this is an arithmetic sequence, I know that AN is the same thing as A5 plus D times N minus 5. You could just count backwards. But I could use that information to find A1. I know I'm flying through this. We can look at another example tomorrow. Okay. But I could have said, okay, well, 32, if I'm going backwards, 32 plus 3, that's the 4th term, plus 3 is the 3rd, plus 3 going backwards is the 2nd, plus 3 is the 1st. Could have done that. And then the question really said, what's B plus C? So that would be 67. All right, just want to throw in some funky notation that you could see on a question that would throw you off, but is not meant to throw you. Oh, well, I don't know if it's meant to throw you off or not, but it's simple. Common difference. If you're given, you have a sequence, you have a term, and you subtract the one before it, it's going to give you the common difference. So some ways you might see that as notation. You might see it like this. AN minus AN minus 1. AN is just some term. So if it's A5 and I subtract A5 minus 1, A4, I'm going to get my common difference. This is saying if N is whatever term it is, you subtract 1, you get the term before it. That is just a funky way of stating what the common difference is. Just means common difference. You could also see it like this. Common difference is any term minus the one before it. So if I said A n plus 1, if I said n was 5, so A6 minus A5, that's a term minus the one before it. That's just saying your common difference. Like your question might say, this, you have an arithmetic sequence, and then it says this equals 2. Instead of just telling you the common difference is 2. But if you see that, it means common difference. Common ratio is similar, but instead of subtracting, you divide. So it would probably be like this. It shows it as a fraction. I think I said common difference, but common ratio. You're not going to see, I mean, you'll probably see that on a question on the test, on this unit test, which is probably why I threw it in there.